Hi everyone, welcome to your last video lesson of geometry. Isn't that exciting? This is 13.4 and it is a doozy. You'll have a lot of fun with this one. It is congruent and similar solids. Remember how we talked about congruent triangles and we talked about similar triangles and similar figures? So similar figures, similarity is when the shape was the same, but they were different sizes. So similar now with similar solids, the math definition is that the corresponding faces are similar and the corresponding angles are congruent. So a simple definition then for similar solids is they are two solids that are the same shape, they're just different sizes. They might both be a cube, but one is bigger than the other. Both be a triangular prism, they're the same shape, they're just different sizes. Okay, so what you really have to pay attention to here is that with similar solids, you compare all the corresponding parts. And if they form the same ratio, then they're similar solids. Okay, so we're going to have an example with one right here on this page. These two pyramids, they are similar. One is bigger than the other, but they are similar. So here's how you know that they're similar. We compare all of their corresponding parts, and they have to form the same ratio. Now before we compare the corresponding parts, I just want to get one more thing because we're going to have to find the surface area and we're going to have to find the volume of these pyramids. So to find the surface area, we do have to find the slant height. And the slant height is the height of the triangle right here. So let's just quickly find that slant height. And what we're going to do here is we're going to do the Pythagorean theorem. The height is 8. This leg right here is 6 because it's half of the base 12. So then if we do 8 squared plus 6 squared, we would get 100, and the square root of 100 is 10. So the hypotenuse of that right triangle is 10. Let's do the same thing on this one. If we have this slant height right here, okay, this slant height, if we have 12 squared plus 9 squared, because that's half of 18, that equals 225, and the square root of 225 is 15. So this length is 15. Okay, now let's compare all of their corresponding sides. So the height of the left pyramid is 8. The height of the right pyramid is 12. Right? And so 8/12, the base, or the length of one of the bases, it doesn't tell you, but it's a square base, so it's a 12 by 12. So the 12 base of the triangle corresponds to the 18 base of the other rectangle. Sorry, I think I said triangle on the last one, rectangle. So 12/18 correspond. And then the slant height we found to be 10 of the left pyramid, and the slant height of the right pyramid is 15. So notice, class, 8/12, that reduces to 2/3, doesn't it? 12/18, that reduces to 2/3. 10/15, that reduces to 2/3. Their corresponding lengths all form the same ratio. Okay, so we would say that the scale factor is 2/3. So now that we know, because of that, we know that the two solids are similar. They form the same ratio. Now I want you to notice something very specific. If we find the surface area of both of these, okay, the surface area of the left pyramid, it would be the area of the base. 12 times 12 is 144. If I want to show my work here, 12 times 12 is 144. And then we have 4 triangles that are all the same. And the triangle, if I were to fold down one of these triangles, 12 would be the base of the triangle, and the height would be the slant height, which we found to be 10. So if we did 1/2 12 times 10, 1/2 12 times 10, we would get 60. And then there's 4 60s. So 60, 60, 60, 60, and then the 144. So the surface area would be, if we add up all those together, 384. So the surface area of the smaller one is 384. Okay, let's do the same thing for the bigger pyramid. So the bigger pyramid would be an 18 by 18. So 18 times 18 That one is 324. 18 times 18 is 324. And then again, the other triangles would be, this side right here is 18, and then the slant height would be 15. So 18 times 15 times 1/2. 18 times 15, 1/2 base times height. So if you multiply those three, you would get 135. And again, there's 4 of those triangles, right? So the surface area would be adding all of those up. So the surface area of the bigger pyramid would be 864. 864. So what is the ratio of the corresponding surface areas? If the ratio of the corresponding side lengths is 2/3, do you think that the ratio of the corresponding surface areas would also be 2/3? Well, let's find out. If we take 384 and divide it by 864, and then we reduce this, let's see if we get 2/3. So we get 384 divided by 864. When we reduce this, we get the fraction 4/9. The fraction of the, or the ratio of the surface areas is 4/9. Okay, so let's see if there's some relationship. We see the corresponding scale factor is 2/3. The ratio of the surface areas is 4/9. Let's kind of do a similar thing. This time let's do it with volume. So the volume of this figure is 1/3 the area of the base times the height. So the volume of the smaller one is 1/3 the area of the base. It's a square base, which is 12 by 12, and 12 times 12 is 144, multiplied by the height of the pyramid, and the height of the pyramid is 8. So 1/3 times 144 times 8, that volume is 384 cubic units. And then the volume of the bigger one is 1/3 the area of the base, and the area of the base is a square again. It's 18 by 18, and 18 times 18 is 324, multiplied by the height of 12. So then we get, when we multiply those three, the volume is 1296. 1296. So let's see what the ratio of the corresponding volumes are. If the ratio of the corresponding surface areas is 4/9, I wonder if the volume is also 4/9. Let's see. 384 divided by 1296. 384 divided by 1296. And this fraction, when we reduce it, is 8/27, not 4/9, even though the surface area one is 4/9. So that reduces to 8/27. Class, do you notice any sort of relationship between the surface area ratio, or sorry, the scale factor ratio with the corresponding sides, the surface area ratio, and the volume ratio? Well, hopefully you should notice that 2/3 squared is 4/9. If you take 2/3 and you square it, 2 times 2 is 4, 3 times 3 is 9, and we get to surface area. And notice how surface area is in square units, or units squared, right? So if you square the 2/3, you get the ratio of the surface area. And then notice how you get to volume. Volume is cubic units. So if you take the scale factor, 2/3, and you cube it, because it's cubic units, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So the relationship between the scale factor and volume is you cube the scale factor to get to the ratio of the volume, 8/27. And that's going to help us solve a bunch of problems with similar solids. So let's just practice one here on the next slide. So if we have the scale factor of the lengths of the solid is 3/5, we can find the ratio of the surface area. We square it to get to the surface area. It's 3 squared over 5 squared. That would make 9/25. So the ratios for similar solids of their surface area, if the scale factor is 3/5, is 9/25. How about the volume? It would be 3 cubed over 5 cubed, because the volume has a cubic dimension. So 3 cubed is 27, and 5 cubed is 125. So that's the relationship for the ratio of the volume. Now let's say we're given the ratio of the surface area of two similar solids. Whoa, let's do that again here. If we're given, whoa, let's do this again here. Why won't this box move? Come on. Well, we'll do this the other way, I guess. Okay, this box, and I think it shows it in your notes, is the fraction or the ratio 16/49. If 16/49 is here, to go from scale factor to surface area, you square. So to go from here to here, you do the opposite of squaring, you square root, right? So the square root of 16 over the square root of 49. The square root of 16 is 4, and the square root of 49 is 7. So the ratio or the scale factor of the corresponding side lengths is 4/7. So now if I want to get back to volume, I cube the scale factor. So 4 cubed over 7 cubed. 4 times 4 times 4, you could just multiply that in your calculator, or if you didn't want to know where the cube button is, I can go to math, and the cubed is that number 3 right there. So if I wanted to take 4 and raise it to the, whoopsies, 4 math raised to the third, 4 cubed is 64. Or I could also go, for the other one is 7 cubed. 7 raised to the third power is 343. So 64 over 343. This equals 64 over 343. Okay, and now let's say we are given the ratio of the volumes. The ratio of the volumes on your example is 64/729. 64 over 729. So if we know that the ratio of the volume is that, to go from the scale factor to the volume, you cube. So to go from the volume to the scale factor, you would cube root. So it's the cubed root of 64 divided by the cubed root of 729. So I'll again show you where that is on your calculator. What number times itself 3 times equals 64? That's what the cubed root is. So again, you can go math, and then number 4 is the cubed root. Number 4 is the cubed root. So it's the cubed root of 64 is 4. And then the cubed root of 729, we go math, whoopsies. So math, number 4, the cubed root of 729 is 9. So 4/9 is that fraction. So this equals 4 over 9. And that is the scale factor. It's the ratio of the corresponding side lengths. So knowing that, we can now find the ratio of the surface areas. It is 4 squared over 9 squared. 16 over 81. All right, now let's see how we can apply that to some actual problems. Here's the first one. The ratio of the edges of the edge lengths of 2 cubes is 7/8. So we have the scale factor. The ratio of the corresponding sides or edges is 7/8. So the scale factor is 7/8. The smaller cube has a surface area, so the surface area ratio would be 7/8 squared. So that ratio is 49/64, right? Now it tells us that the smaller cube has a surface area of 98. What is the surface area of the larger cube in square inches? So if the ratio is 49 over 64, and we know the surface area of the smaller one, it's 98. So that would equal 98 over what is the surface area of the larger cube? That's our variable x. Now we can solve this proportion. We would cross multiply. 64 times 98. That is 6,272. And that equals 49x. Divide both sides by 49. If these two cubes are similar, and one has the surface area of 98 square units, then the other one is 128 square inches. And there's our first example problem. Our last one, very in depth here. It tells us that we have a cone that has a surface area of this much and a volume of this much. And then we have a similar cone, so a similar solid. It has a surface area that's bigger, right? So what is the volume of the bigger cone? Okay, so let's find the ratio of the surface areas, because we know both surface areas. The surface area of the big cone is 602.88. So this is our surface area spot. Okay, the surface area of the bigger cone, is 21,703.68. So let's find what reduced ratio this is. What does this equal? 602.88 divided by 21,703.68. Let's see if I can remember all that. 602.88 divided by, the other surface area is 21,703.68. What ratio does this reduce to? Math, enter, enter. Let's get rid of all my red marking here. All right, it reduces to 1/36. So the ratio of the surface areas is 1/36. This equals 1/36. So I need to know what the volume is of the bigger cone. So I need to know what the ratio of the volumes is. But before I can get that ratio, I first have to go back to the scale factor ratio. Because in order to get the ratio of my volume, I have to cube the scale factor. So how do you get from 1/36 to the scale factor? You square root. The square root of 1 over the square root of 36. So the scale factor ratio is 1/6. Each part of the smaller cone to the bigger cone is 1/6 the size, or the bigger cone is 6 times larger. So now knowing that, I could say my volumes, I'm going to cube 1, and I'm going to cube 6. That's the relationship between the scale factor and the volume. It's cubed as much. 1 cubed is 1, 6 cubed is 6 times 6 times 6, I believe, is 216. Okay. So now with this ratio, I can say that the smaller cone to the bigger cone has a ratio of 1 over 216. So if the smaller cone has a volume of 7,502.5, then what is the volume of the bigger cone? I simply cross multiply this and I get my answer. X equals 7,502.5 times 216 is 1,620,540 cubic inches. Congratulations, everybody. You have now successfully completed all of the videos in geometry. You should be proud of yourself. Good work. Let me know if you have any questions when you get to class tomorrow.